Hi, I'm Ron Jordan with Focus on Energy, and we are in Fitchburg at the Net Zero Ready home, Jackie and Kevin's home. It's coming along. Today, the building performance consultant is going to be here with a few other people. We're going to be checking just how energy efficient their home has been built. If you remember, at the end of the construction, once the solar panels are up and everything is going and working perfectly, their house should be as close to net zero as possible. But to get there, they have all of these other things in the house, products, energy efficiency products, the insulation upstairs, and all of this is going to be tested right now. So let's check in and see what they're going to be doing. Jackie, here we are. It's a big day in your house. What's happening?
Welcome back. We have the building performance consultant on site to conduct a variety of tests. Remember Joe? Joe was here before the drywall went in,
Right.
doing a test to make sure everything was in place where it needed to be. So today he's back to run some tests, check the mechanical equipment, make sure it looks good. And this is like one of the final steps to getting the certification that we want with Focus on Energy through the New Homes program.
And so we're looking at the blower door, vents, everything else. We're checking out just how energy efficient your home is at this present moment.
Exactly. Yeah. We're aiming big. I think I've said that before, that we really hope that we'll hit the air changes per hour. We're looking for 1.5 air changes per hour, 50 or less. And in terms of the ducts, I'm not really sure what the metric is there. So we'll find out today.
Awesome. All right, let's check in with them.
Cool. Hi, Joe. Good to see you again.
Good to see you, Jacqueline.
This is a big day for us. We're testing the performance of the home. I'm curious, can you tell us just a little bit more of what I can expect to see today?
Well, sure. First off, if you remember in the energy model, we had the takeoffs from the building file. We had all the inputs for the construction products, but we always have to put in an estimate for the building tightness. We have to put in an estimate for the duct test tightness. So now today we're going to confirm those values in the as-built form. So we'll be doing a blower door test to test the tightness of the building. We'll enter that information into the software. It'll convert that into an air leakage rate. And also on the duct system, we're going to be doing a total duct leakage test. And then we'll be testing the ventilation equipment. We'll be testing the bath fans too. And then that input will all go into the run rate model.
So going back to the blower door, what's a good score for that?
Well,
That's what you call it.
Well, this is a fair question. What's interesting, right, is there's very seldom ever two buildings exactly the same physical size, but we can appropriate an estimated number up front for a target. For instance, Tim O'Brien Homes likes to shoot for 1.5 air changes at 50 pascals as a goal. And when you convert that to natural leakage, when our equipment is gone and the weatherman is just impacting the building, that's very, very tight. But in the end, when you're anywhere near close to that, the software will easily show that there's not much of an impact on energy. But I would say that with the work we saw so far, that we're probably going to be better than that. But we'll look for that. Yeah.
Okay, cool.
Yeah.
Is there an average that you've seen for homes in Wisconsin?
Well, in all fairness, I have to say buildings in Wisconsin are very tight. I mean, we've done characterization studies and buildings are very well done. And in all fairness there, what we oftentimes see is that buildings are sometimes done real well on air tightness just by accident. And then no one pays attention to indoor air quality or the duct system or some of those other features. So here you incorporated all those features that we're looking forward to finishing up the run rate file.
Yes. Okay, so some work's already been done. What was the first test that we did?
Well, to be able to make it efficient for our consultants, we always start with the duct testing first so we can work our way from the basement out of the building.
Okay.
So we did the total duct leakage test, the integrity of the system with it all capped off, and then we did a duct leakage test for leakage to outside to make sure that that's not communicating with the duct system to the outside when the air handler's running. So those two are done.
Okay, what's next?
We'll go up and, given that we had the blower door set up for part of the duct testing, we'll go up and do that next and pull that one off.
Okay, I'm really excited about that one.
This is the part that I'm really excited about. I love the air blower door tests. So, Joe, tell us what exactly is going to be happening now. I noticed that it switched. You switched the fan. You turned it around.
Mhm. Well, to do the blower door test, we prefer the depressurized building, so we had it in reverse mode for the duct testing part. So right now, our technicians got it set up so that we'll be drawing air out of the building to generate a -50 pressure between the inside of the house and the outside. That's the industry standard for doing blower door tests. And you'll be able to see the pressure on the fabric once the fan fires up. What's neat about it nowadays, though, is that with all the automated features in technology and the smartphones, Curtis is able to run the actual fan off of his smartphone back there. It's communicating with the electronic instrumentation. And what the software is set up to do is to run the pressure on the building at 5 different pressures. And then it'll plot those points on a curve or on a chart to make sure that they're in line for the accuracy of the test. And at the end, it'll then convert that to some numbers that we were talking about before with additional information you already plugged into the smartphone about the size of this unique building and the weather conditions. But again, we need to do the blower door test to verify the construction tightness. It's often misrepresented that a blower door test tests for the natural building leakage. That's not possible. We operate buildings in the wintertime in a heating climate only at about 4 pascals of pressure, about what you get when you say the letter P, very tiny. But we can't test at that 4 because the accuracy would be not even on the map. So the industry over many, many years has established to do it at 50 pascals, 45, 40, 35, 30, and so forth at high pressures so that the accuracy is very well established. And then the software will project what the actual number looks like at those normal operating conditions. We'll take the results of this test, plug it in our run rate building model, and then have the software show us the impact on operating costs related to the tightness of this unique building. No 2 buildings are the same. You're going to wind up with different blower door numbers. You can compare other factors of that result. But this is why we need to get to this point to see how well they did.
I have a question.
Yes.
What if the number isn't good? Like, can we find where the leaks are? How do we do that?
Well, that's the interesting question, right? Because people, you're not the first to ask that. Well, we're hoping that it's very good
Yes.
on the number because trying to find leaks now are very interesting. You could chase it down with a thermal imaging camera if you have enough temperature difference. So when we're reefing on the building, we're drawing outside air in. So if there's any leaks, the air would be coming in. But in a building done this well, they're going to be so small, you'd have a hard time chasing them down. That's why we always do site visits during construction,
That's right.
working with the construction manager and the construction company to point out and make sure everybody's on goal with all the different construction features, because chasing down small leaks at the end is very, very difficult. And sometimes even if you could identify a leak at that elevated pressure, you might not be able to get at it. The only time you can really get at them is during construction,
Right.
But you'll be just fine.
All right, well, let's let them get to work.
Here we go.
All right.
So we're upstairs, master bedroom, master bath, and we're going to be doing bath vent tests. Correct, bath fan tests.
When you build a nice well-built home like you have here, Jacqueline, we still want to make sure that basic features function, right? I mean, whenever you take a shower, you really like the moisture to be leaving the building. If you generate some odor, you'd like that to be removed as well. And in order to verify that that can happen is we need to measure the airflow on the exhaust fan in the bathroom. So we have a digital flow hood here that we hold up. It's got a capture on it. We just simply hold it up. When the fan is running, it displays the digital value. We can look at that and then say, okay, it's 110 rated CFM, for example. What are we actually getting for airflow?
Yeah.
We kind of look at it like taking a test. If 100 is a good test, would you be happy if you were only getting 60%? Probably not. We like to see bath fans up at least 75% of rated airflow. Now, the minimum code in Wisconsin is 50 CFM tested airflow, regardless of how big the fan is. But we're still trying to work with the building community to get a better percentage of the rated flow for what they bought. And the only way you'll know that is to test. Whether it makes noise, whether it's 1 foot from the outside, it makes no difference. If you don't test, you know nothing.
Yeah.
And in order to be able to assure homeowners they have the capability of managing moisture at a basic level, you really need to test. We test every fan in every home that goes through the Focus on Energy program.
Well, I'm glad you're here. Let's go.
Let's do it.
All right. Curtis has got this set up for us, and the capture hood allows us to be able to get around great big grills like we have here. And it's got a gasket that seals to the ceiling, and it'll just instantly ramp up and measure the actual airflow in cubic feet a minute that's leaving the building through the fan. And it's got a lock feature on top, so if we have to move this away from the ceiling, we can just punch the button once it stabilizes. And we see that it's recording an airflow of 82 cubic feet a minute. Now I think when I was here that this is rated at about 100 CFM, this built-in fan that's part of the heater system.
Yeah.
But the exhaust fan to the outside is doing 82. So we don't have to take off our shoes to do the math on that, right? If it's 100 CFM, we're doing 82% of rated airflow. And that's a good setup.
That's a good setup.
Yeah, because if you think about it, the fans are rated with no ductwork on them and no fittings. Well, this fan here, when I was here during the rough-in, the ductwork goes all the way across the ceiling here to the outside. And we look at that during rough-in, and they did a great job of doing a nice termination on the outside. They supported the ductwork all the way to the fan. So 82 on 100 at 82%, that's very good.
Great.
And now make sure you turn it on.
That's great. Okay, so one of the last tests of the day, the infrared scan. What are we looking for with that?
Well, the thermal imaging, also called infrared scan, allows us to see temperature. That's all these cameras do. That's why it's a thermal imaging camera. It allows us to set up a color palette that allows us then to see where there's temperature differences. Obviously, you'd expect to see a little bit of a cooler surface wherever there's framing in the wall. You'd
Okay.
expect to see a cooler surface of the window. But we use it more or less in quality assurance to make sure that maybe a section of the attic didn't get insulated. Sometimes we can't get up there and crawl around, which we normally do, but we can go to the second floor of a building or the first floor if it's a ranch, take the IR camera and then scan to make sure everything is not only completely insulated, but it looks uniform in color.
Okay.
These do not give you R value. They do not give you thermal value.
Yeah.
They are simply a display of color differences, which is why people have to be a little careful when they use this stuff. But we use it to make sure we can see. And then, as was talked about earlier, if you were trying to find leaks in a building, we could then combine the blower door equipment with the thermal imaging camera, draw the building down or pressurize it as long as we got enough temperature difference, and the air moving in and out of the building would change the surface temperatures where the airflow is occurring by a leak. So it allows us just to plot temperatures, but we just have to make sure we're careful on what we interpret from those temperatures.
Okay, well, let's get started on that one.
Okay, what we looked at here today in terms of the actual tested building with the photovoltaics was that I wanted to look at the end consumption in a fuel summary report. So here I can see that on the annual consumption, the photovoltaics are going to generate about 18,397 kilowatt hours. And compared to the estimated load, it only leaves us with a difference of 556 kilowatt hours to purchase. And that's very, very small. So we're happy on that. Now, if we go ahead and look at a quickie report for the codes to look at, say, the HERS index, and we do a calculation there, when I hit the hourly calculation button, it'll give us the final HERS index. Now, I do have to do a couple of minor tweaks to the building file, but nothing that will impact this. And obviously with the HERS index, where people are trying to get to zero, right? No purchased energy. And let's see what this animal looks like here once. And it shows up a -6 on the HERS index. That's spectacular. Most of the DOE solar decathlon homes that I've been involved in sometimes don't get to that point. So that's very, very good. Also on some of the code references, those are 0 as well. It's 104% better than the Uniform Dwelling Code here in Wisconsin due to the on-site generation, as well as the excellent building shell that they built here, including all the mechanicals and the features of the building. So we're very happy the way things tested out today, and the numbers certainly represent that.
All right, Jackie. Well, this was the big day. You saw them doing all the work. What do you think?
Things are looking really good. I'm very pleased. Kevin will be pleased too. And really just having that reassurance with the building performance consultant here to check things, to make sure, because I wouldn't know what to all look for, right?
Right.
So having these tests, like, I'm just feeling really good and I want to move in.
And so is that the next step? Like,
That is the next step.
Moving is
We're
next.
1 week away from moving in. So we'll settle down a little bit and I'll invite you back.
that would be
And we'll see
great.
how things are
I'd
going.
like to sit here in this fireplace. It's pretty
Yeah.
awesome. So thank you for joining us for this episode of Building a Net Zero Ready Home. We'll be back in a few weeks. Make sure you hit subscribe and watch all of the episodes, and we'll see you soon.